Good morning, students. So today we are going to discuss the pH of a solution, then universal indicator, then reactivity of acid and bases. In this topic we will study neutralization reaction, then reaction of acids with metals, then reaction of acids with oxides of metals, reaction of bases with oxides of non-metals, reactions of acids with carbonates and bicarbonates of metals, salts or types of salts, acidic, basic and neutral salts, and finally water of crystallization. Okay, so these all topics we have to study today. Then your first topic is the pH of solution. So what is pH of solution? I will explain with the help of theory. Okay. So you can see we have seen that acids and bases dissociate to a smaller and larger extent on dissolving in water, forming H plus and OH minus ions respectively. That is, if you dissolve or if you if you dissolve acid into the water, it gives H plus ions, and if you dissolve base into the water, it gives OH minus ions. I have explained this all in the previous lecture. Okay. H plus ions and OH minus ions are found in different proportions in all natural aqueous solutions, and that determines the properties of those solutions. That is, if in any solution the concentration of H plus ions is high, that will be more acidic, and if the concentration of H plus ions in any solution is less, then that is weak acid. If the concentration of H plus ions in any solution is high, then that will be more acidic or a strong acid. Similarly, in case of OH minus ions, if in any solution the concentration of OH minus ions is less, then that will be weak base, and if the concentration of OH minus ions in any solution is high or is in large extent, then that will be more basic, or that is strong base. Okay. For examples, the proportion of H plus and OH minus ions divides soil into the acidic. On the basis of proportion of H plus ions and OH minus ions, we can divide soil into three categories. One is acidic, second is neutral, and third is basic type of soil. Okay. When a soil will be acidic, if soil is acidic, it means what? It means there is a large number of H plus ions as compared to OH minus ions. Okay. If a soil is neutral, that is number of H plus ions and OH minus ions is equal. If a soil is basic, that is number of OH minus ions is large as compared to H plus ions. Okay. Even fermentation carried out with the help of microorganism, other biochemical processes, and also may chemical process requires the proportion of H plus ions and OH minus ions to be maintained within certain limits. Even in fermentation, H plus ions and OH minus ions play a very important role. Pure water also undergoes dissociation to a very small extent and gives rise to H plus ions and OH minus ions in equal proportion. See, even simple water H2O dissociate into H plus ions and OH minus ions, but in very less concentration. The concentration may be different or in very less extent this dissociate. Okay, so here is one chart is given. So this is this you have to learn. Neutral, if this is the pH means potential of hydrogen. So this is solution, and this is whether solution will be acidic or neutral or basic, strong bases. So this is the reference point. 7 is a reference point. So if any solution have pH less than 7, then that will be acidic in nature. And if any solution have pH more than 7, you can see 7.4, 8.5. So in that case, that solution will be basic. So if you move from this side, if any solution have pH 6 and if any solution have pH 1, which will be more acidic? So always remember, the pH having 1 will be more acidic as compared to pH 6. Similarly, if you move in this side, then solution will become more basic or a strong base. If you compare, if for example blood have pH values 7.4, this is more than 7, so blood is basic in nature. And if you compare blood and lime water having pH 11, so which one will be more basic? So lime water will be more basic because pH is 11, that is more than 7.4. But in this case, if you move from this side from 7, then solution will become more acidic. Understood? For pure water, sugar solution is a neutral solution. That's why we drink water. Okay? So if I say give one example of a strong acid, so you can say HCl, 1 m, 1 molar HCl. 1 m means 1 mole per liter. The m is molar. In the previous lecture I have explained you. And similarly, give one example of a strong base, so you can say sodium hydroxide, NaOH. pH having 14 will be the strong base. One thing you have to remember, the concentration of H plus ions formed by dissociation of water at 25 degrees Celsius is I am talking about concentration of H plus ions in case of water at 25 degrees Celsius is 1 into 10 raised to minus 7 mole per liter in case of water at 25 degrees Celsius. But at the same temperature, the concentration of H plus ions in 1 molar solution of HCl is 1 into 10 raised to 0 mole per liter. Okay, but at same temperature, if you talk the concentration of H plus ions of sodium hydroxide, concentration of OH minus ions is 1 into 10 raised to minus 14 mole per liter. Thus, we see that common aqueous solution, the range of H plus ions concentration is very wide, from 10 raised to 0 to 10 raised to 14 mole per liter, right? Okay. So therefore, the value of pH, this is the concentration, this is the range of concentration, 10 raised to 0 to 10 raised to minus 14 mole per liter. But if you talk about pH value, then that is from 0 to 14. This is, I am talking about pH, that is potential of hydrogen. The value of pH, the range of pH is 0 to 14. Okay. Your next topic is universal indicator. Your next topic is universal indicator. So what is universal indicator? So we can say a universal indicator is made by mixing several synthetic indicator in a specific proportion. This word is important. A universal indicator is made by mixing several synthetic indicators in a specific proportion, right? The pH of a solution can be determined by means of universal indicator solution or pH paper made from it. However, the most accurate method of measuring the pH of a solution is to use an electrical instrument called pH meter. So with the help of universal indicator, we can find the value of pH of any solution, but that will be not accurate. But if you want to measure accurate value of pH of a solution, then you have to use pH meter, that is an electrical instrument. Okay, so this, you can see, this is the pH meter. With the help of pH meter, we can find the value of pH of any solution that will be more accurate as compared to universal indicator. Okay, so actually universal indicators, for examples, I want to tell you, if you take one solution, like if you have taken HCl in any beaker, say this is HCl, one beaker, for say this is a beaker, there is HCl, right? And if you add one drop of universal indicator, then this color will be changed and this will turn into red in case of acid. Okay, and if you take sodium hydroxide, that is NaOH, this is base, and if you add one drop of universal indicator, the color will be turns into blue. That indicate that is basic. See, if you take water in the beaker, distilled water, and if you add one drop of universal indicator, then its color will be green. So green means that is neutral. Green means neutral. So you can see here, if color developed in this beaker is green, that will be acidic, and if in this color of the solution becomes red, that will be acidic, or that solution will be acid. And if color of the solution turns blue, okay, then that will be base. Understood? The next topic is reactivity of acids and bases. So in this topic, first topic is, what is neutralization reaction? What is neutralization reaction? So simply, when acid and base, or we can say, what is neutralization? So we can define neutralization is a process in which acid and base reacts to form salt and water, right? It is the process in which acid and base reacts to form salt and water. One acid I have taken here, that is HCl is the acid, okay, and NaOH is a base, right? So from here H and here OH, it forms H2O. One H here, one H is here, H2O is here, H2O, and Na and Cl, that is NaCl, is a salt that we use in our day-to-day life. Sodium NaCl means sodium chloride is a salt. So always remember, if questions come what is neutralization, then you have to write it is the process, or you can write a reaction. It is a reaction in which when acid and base reacts to form salt and water is called neutralization reaction. So this is the acid, this is the base. So always remember, when acid and base react, it will form salt and water. For example, HNO3, this is acid, and this you have to fill. This you have to fill. So you can see here, this is the reactant. This is reactant. There are two reactant. One is HNO3, that is nitric acid, and here is blank, that you have to fill. So here is two product. First reactant number one, reactant side. This is reactant side. This is product side. Two reactants are there. This one and this one. That is nitric acid HNO3, and this here you have to fill. So you can see here there are two products, potassium nitrate KNO3 and H2O water. So this is the salt. This is H2O here. It means this is K is here. K is here. It means here must be, this is acid. So there is this is base. In the base there must be OH. There must be OH. So here is OH and here is K, that is KOH, potassium hydroxide. So here will be KOH. Similarly, this you have to fill. So you can see here base is given. OH is here. It means in any substance, if you see there is OH, that will be base. And you can see here salt is given and water. The water you have to write H2O, okay. So you can see here is SO4. So in which acid SO4 comes? So that is H2SO4. That is H2SO4. So here will be H2SO4. Similarly, this you have to fill. OH at the place of base, KOH, OH, and you can see here water, that is H2O. Here is KBr. So here must be Br, and acid, so HBr. Okay, so this type you have to fill. The next topic is reaction of acid with metals. This is escape. This is escape. No need to study this one. Okay. try this is also excluded. So your first topic is reaction of acid with metal. It means metal will react from acids. Okay. So so always remember, whenever metal react with acid, dilute acid means there is water in the acid. Okay. Always remember, when metals react with acid, it forms salt and water. Corresponding salts and water. If you take here magnesium, then magnesium salt will form. If you take here the zinc corresponding zinc salt will form here. If you take some other copper salt will form here. So salt depends on which metal you are taking here. So when acid react with metal, it form corresponding salt and water. Sorry, not water, this is hydrogen gas. Hydrogen. Always remember. So whenever this is wrong written here, water, that will here will be hydrogen. So whenever metal reacts with acid, it forms corresponding metal salts plus hydrogen gas. Okay. For example, magnesium S means solid. Magnesium, they are found in solid. HCl. 2 is a number. No need to learn 2. Whenever you will balance this equation, then automatically here 2 will come. So 2 is used for balance the chemical reaction. Okay. So Mg is a metal. Magnesium is a metal. It is reacting with HCl. Hydrochloric acid. Aqueous means water is present in the HCl solution. It forms Mg and Cl. So in that case, magnesium chloride will form, that is salt, plus hydrogen gas. This hydrogen gas will release. Similarly, zinc is a metal and H2SO4 is a acid. So metal is reacting from acid. It forms zinc sulfate and hydrogen gas H2. Here H2 will come. H2 gas is releasing. Okay. Similarly, you can fill here on the basis of product. You can see here copper nitrate is here. Here is hydrogen gas. So here must be copper. Since here is copper, so there must be a copper and NO3. At the place of acid, you have to write HNO3. That is nitric acid. Okay. So reaction of metal with acid I will show in the practical in the lab. Whenever school will open, I will show this practical. Hydrogen gas will form. So I will show in the lab, school lab. Okay. Your next reaction is reaction of acids with oxide of metals. Reaction of acids with oxides of metals. Oxides of metals. Okay. So always remember, when metal oxide means what? Calcium oxide. Calcium is the metals and here is oxide. So we can say calcium oxide is the metal oxide. Similarly, Mg is a metal and oxide. Metal oxide. Magnesium oxide. So this is metal oxide. When metal oxide reacts with acid, it forms corresponding metals salt plus water. Always remember. So if questions come like what will be the product when metal oxide reacts with acid? So your answer should be, when metal oxides react with acid, it forms corresponding metal salts plus water. In the previous reaction, we have studied when metals react with acid. In that case, salt plus hydrogen gas is released. But in case of when metal oxide react with acid, it forms salt and water, right? For example, if you take one metal oxide, calcium oxide, S is a solid, aqueous means water is mixed in the acid. So if calcium oxide is the metal oxide, react with dilute acid, that is HCl, it forms calcium chloride. Corresponding salt means what? If you have taken magnesium, calcium, here is HCl you are taken, then calcium chloride, that is a salt, plus water, H2O. This is fixed. Water is fixed in all the reactions. It will vary. Salt will vary according to metal oxide you have taken. Which metal oxide you have taken, on that salt depend. Okay. Similarly, if you have taken zinc oxide, ZNO, plus HCl, it forms again zinc chloride plus H2O. Okay. So always remember, whenever metal oxide react with acid, it forms salt and water. Okay. Your next reaction is reaction of bases. In this type, we are going to take base. It means what? It means, in that is bases. It means OH. There must be OH present in the base. Okay. So reaction of bases with oxide of non-metals. This is non-metals, oxides of non-metal. For example, this is carbon, this is oxygen, this is carbon dioxide. This is again oxide, but this oxide is of non-metal. Carbon is a non-metal. So here we are going to take oxides of non-metal. Similarly, SO3. This is oxide of sulfur is a non-metal. So oxide of non-metal. So when base react with oxide of non-metals, it forms again salt plus water. For example, CO2, carbon dioxide, G means gas, carbon dioxide is a gas, we all know. This is sodium hydroxide. How to read all the compounds I have already explained in the previous chapter. So carbon dioxide is the oxide of non-metals, and sodium hydroxide is the base. It forms again salt plus water. So see, water is fixed in all the reaction, and salt depends on these metals. This is NaOH, sodium hydroxide, and here is CO2. It means salt will be formed sodium and CO2. That is, we can see here after practicing. If you practice the reaction, then automatically you will understood CO2 will convert here CO3. So here is sodium carbonate plus H2O water. Okay. So similarly, these all reaction you can fill all the compounds here. This is excluded. Use your brain power. One thing I want to tell you, what is amphoteric oxide? So amphoteric oxide reacts with acids as well as base. Okay, that is called amphoteric oxide. So next reaction we are going to study reaction of acid with carbonates and bicarbonates of metals. Reaction of acid will be there. Reaction of acid with carbonates and bicarbonates of metals. So you can see here, when carbonate salt of metal reacts with dilute acid. Carbonate salt of metal, it means ki in all the compounds there will be carbonate, that is CO3, 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 and these all are the carbonate salt of metals. Carbonate salt of metal, here is sodium, calcium and potassium. React with dilute acid, it forms another salt of metal and carbon dioxide gas. So whenever carbonate salt of metal react with dilute acid, it forms another salt of metals plus carbon dioxide gas. This is fixed. Carbon dioxide plus water also. This water plus, you can write here water, H2O will form. Always remember, whenever carbonate salt of metal react with dilute acid, it forms another salt of metals plus carbon dioxide plus water. Water is missing here, so you have to add water also. So you can see here carbonate salt of metal. So here sodium carbonate, means this is carbonate salt of which metal? Sodium metals. React with dilute acid. Here acid is HCl. You can take here, in some cases you can take H2SO4, that is sulfuric acid. So it forms another salt of the metal. So see, from here you will take Na and here you will take Cl. So that is NaCl plus CO2 is fixed plus H2O, water is also fixed. Similarly, this is here what you will write here. So you can see here Na2CO3, that is sodium carbonate, that is this is the carbonate salt of metal sodium. It is sodium, this is the carbonate salt. This is carbonate salt of which metal? Sodium metal. This you have to fill. So you can see here Na2SO4 is here. Na2SO4. That is, this is the another salt of sodium. This is the another salt. This is the, you can say, this is the sulfate salt of sodium metals. Or okay, this is carbon dioxide will be here plus H2O will be here. So you can see here first, similarly you can see Na, you are taking in this case NaCl, you are taken first one and last one. So here you can see here Na is here, Na is here, at last you will take SO4. So here will be sodium sulfate. SO4, in which acid SO4 comes? So in H2SO4 SO4 comes. So here will be H2SO4, right? It gives sodium sulfate plus, this is fixed, carbon dioxide plus water. In case of when carbonates of metal, carbonate salt of metals and acid reacts, carbon dioxide plus water, that is fixed. Similarly, in case of here is carbonate salt of metal, here is bicarbonate salt of metal plus acid reacts, it forms again another salt of metal plus, this is fixed, carbon dioxide, that you have to write in all the reaction, and water you have to write all the reaction. Okay, so in here you have to take bicarbonate salt of metal. So HCO3 means bicarbonate. HCO3 means bicarbonate. Only CO3 means carbonate. So if you add H, that is then that case you have to read bicarbonate. Okay. So bicarbonate of which metal? Here is sodium. Bicarbonate of which metal? Here is sodium. So when bicarbonate salt of sodium metal reacts with HCl or acid, it forms again another salt of metal. So again you have to take first one example you have to learn. This first one and last one you will take. So this is sodium chloride will be formed here plus CO2 plus water, H2O. L means liquid, G means gas, aqueous I have explained you. Okay, so in this way you have to fill all the table. So I will explain next in the next lecture water of crystallization and ionic compounds and electrical conductivity and electrolysis of water. We will explain the next lecture. Okay, one more lecture I will take from this chapter then we will start next chapter. That will be physics, chapter number maybe 11 or 10, maybe 11, reflection of light. Okay, thank you.